Welcome to the LeoAFO tutorial video. First, click Import and navigate on your desktop to find your STL or OBJ file. Use your mouse scroll wheel to zoom in and out. Use the right-click mouse button to rotate your model and click and hold your scroll wheel to pan the camera view. You may also use the transparency slider to change the opacity of your model and to toggle on and off the ground plane and landmarks once they are completed. You can also use the measurement tool to measure distance between 2 points. Girth can be measured by selecting 3 points around the region of interest. Check and make sure that your scaling units match the export units from your scanning device. Transform and reposition your model as needed by clicking and dragging the on-screen rotation wheels in any plane. You can toggle between rotate or move to vertically or horizontally reposition your model as needed. When you are satisfied with the model position, you can move on to the clean step. If you need to, click and drag a bounding box and use Delete on your keyboard to remove any triangles. You can also click the undo arrow. You can smooth, fill holes, or remesh. We recommend remeshing if you have a large file on import. Next, move on to landmark application. Follow the list on the screen and make sure to accurately place every landmark requested. Whichever landmark is highlighted on the list will be applied to the model with each click. You can click multiple times and double-check that you have it in the best location, and then when you're ready to move on to the next landmark, you can click the next item in the list. When you're done placing landmarks, you can pick from one of the 2 alignment modes and then hit Apply to move on to Mesh Editing. The various tools are posture correction, loop transformations, pressure or reliefs, and freehand sculpting as needed. You can start with posture correction to change the relative angle of any joint segment. Use the sliders or type in a numeric value. When you're done, hit Apply. If you wish to add a pressure relief, you can select one of the preset reliefs from the drop-down menu by selecting it and clicking Add Shape. Then, the pressure map will appear. You can change the apex by clicking and dragging the center point, or change the boundaries by dragging any individual control point. Or you can press the Control key and move all the points as one unit. You can change the depth or height of the relief with the slider, or by typing in a number, and then hit Apply. If you wish to add something similar on the other side of your model, you can do so easily. Or, you can pick any other options from the drop-down list. Features like met pads, styloid process reliefs, or navicular reliefs can easily be added. You can then move on to the sculpting tool to smooth out any modifications that were added manually. Use the sliders to quickly change the effective radius of the tool or the strength of the smoothing or flattening. Once you're done with your modifications, you can click through to the Design tab. The first design will show up automatically with a toe box already generated. You can change designs by selecting a design and clicking on one of the various templates to get a preview of the trim lines. It is possible to get your proprietary designs added for your access, or to customize existing templates with company logos and branding. Click Generate AFO to get an idea of what the finished device looks like. If you wish to edit the design, you can do so under Edit Design. This model has two layers, an inner and an outer layer, and you can toggle between them here. If you want to hide the outer layer, you may do so, or hide the inner layer as well. Each template utilizes a variety of features or components that can easily be modified to achieve your goals. All templates will include an outline or primary trim line. This template also incorporates patterns and variable edge thickness. The edge thickness map controls where and by how much the footplate thickness will taper. You can deactivate any feature by clicking the toggle switch labeled Enable Component. For example, you can turn the pattern off or turn it back on. You can change the distance between ventilation holes or the radius of each ventilation hole. In this case, we can make a pattern with a lot of really small holes, or increase the distance and radius to generate fewer, but larger holes. If you wish to suppress it entirely, you can turn it off and then regenerate. This is true for any tool, including the rear footpost, which can be turned off, or the shape can be edited by clicking and relocating the control points. The Expand slider controls the amount of taper applied to the heel post. The larger the number, the less taper will occur, leading to a more square edge. The lower numbers will have much more taper and rounding. We'll cover the shank angle tool when we switch to a taller AFO design a bit later. The toe box can also be turned on or off, and multiple variables can be adjusted, like viewing opacity. Additional length can easily be added. The height of the toe box can be manipulated, and also the roundness of the edges. The ramp height and relative shape and curvature can be changed as well. Additionally, the blending of the toe box into the model can be adjusted by using the MPJ offset and the transition sliders. If you switch to a different design template, different tools, features, and components will be available if you edit the design. This template does not have an inner layer, so it cannot be clicked here, but there are now multiple additional tools available, like the reinforcement, which actually generates the plantar stop at the back. The different thickness tool makes a secondary trim line to add entire device rigidity. Also available is pattern control and cutout, which places each of the individual strap slot locations. Edge thickness will be for the dorsal wings to control the gradient thickness across the length of each wing. And additionally, another gradient thickness for reduction of the thickness of the toe plate. A tool that is unique to the articulated AFO template that isn't available on other designs, but is used here, is the ability to control the joints. This will help position your articulations as needed. You can select the placement method of the joints using a medial or lateral locating landmark. The anterior or posterior positioning of the joint can be changed with the AP slider and proximal distal position with the vertical position slider. The rotation of the joint body will be adjusted here, and thickness of the shell and the offset away from the model can be adjusted. Here, the curvature of the cut-through can be changed on the lower and upper limits, and positioning of the cut can be adjusted in multiple ways. If the joint is placed outside of the trim lines, or there is some sort of interference with the cut-through curves, you will get an error message when you go to generate the AFO that says, "Joint components joint generation has failed." The problem will be highlighted in red, and you will need to fix the problem and regenerate the model accordingly. Another useful tool is the Emboss text tool, which can be used to engrave in a line of text for the patient name or other tracking number. The positioning of the green text box can be rotated with the rotation slider. Also, the size of the font can be scaled up or down. The depth at which the text is cut into or raised up from the model can be changed as well. And for a small fee, your company logo can be added. Click to place the green box on the model and hit Generate AFO to preview the device with the emboss. If we switch to a template with a taller design, we can now see the effects of adjusting the shank angle. Modifying the shank angle will incline or recline the finished device accordingly. The difference can be seen here. Trimlines can be edited easily by adjusting the blue control points to move the line, or by grabbing one of the associated two green points to change the roundness or shape of each section. The reinforcement tool can be used to modify the parameters of reinforcement bars. Move the curves around to change position and length, and use the sliders to add additional thickness, offset, or transitions. The cutout tool can be used to modify the parameters of the strap slots. Reposition it, change the height, or change the roundness of the slot as needed. You can also change features like flexible edges or hole placement for laces. To start editing, click on Edit Design. Click on Outline to edit the trim lines, and if you click and move one of the points, the device will disappear so you can see the curves defining your device. The different thickness tool can be used to define a thin region around the heel. It can also be used to define the flexible edges. By pulling the secondary trim line away from the primary trim line, the size of the flexible edge can be adjusted. The lace holes individually can be relocated to maintain a symmetric appearance and ensure robust design. When you have completed your design and you're happy with the results, you can go to File, Export, and pick your export type, then export the finished device to your desktop. Congratulations on your finished design. You can print it, fit it, and rejoice over how much time you saved throughout the design and fabrication process. Don't hesitate to reach out if you have any questions.